Hi, I'm Bob. Welcome back to 5 Minute Econometrics. We have just learned the F-test for multiple exclusion restrictions. The F-test is useful for the joint hypothesis test for a group of variables when they are highly correlated. In this case, the individual t-test may lead to individual insignificance due to strong multicollinearity. The F-test can be used to determine whether the group of variables are jointly statistically significant. Today, we will explore the relationship between the F-statistics and the t-statistics. I just mentioned the situation in which the individual variable is insignificant, but the group of variables is jointly significant, such as our previous example of baseball players' salaries. In this example, we should report that the three performance measure variables as a whole have a significant effect on wages at the 1% level, because they are jointly significant. The opposite case is also possible. That is, in a group of explanatory variables, one of them could be statistically significant, but the group of variables could be jointly insignificant at the usual significance levels. In that case, we should report that significant variable. We can use the F-test for a single explanatory variable. The F-statistic will be equal to the square of the corresponding t-statistic. For example, this model relates workers' hourly wages to their educational attainments, gender, health status, marital status, age, race, region, and family backgrounds, like their parents' income and education. The t-statistic for the variable schooling equals 20.25. Its p-value is 0 to 3 decimal places. We can use the test command to find the F-statistic. The F-statistic for schooling is 410.14, which is approximately the square of its t-statistic. A precise calculation can be performed as follows. Using the return list after regression, we can find the OLS estimates vector and the variance-covariance matrix. With this information, we can compute the precise t-statistic manually. Then, we can calculate the F-statistic from the restricted and unrestricted models. We store the sum of squared residuals and the degrees of freedom from the unrestricted model we just regressed. Next, we regress the restricted model, in which the restriction is imposed. The restriction is that the parameter of schooling is 0. Be careful to use the same sample as in the unrestricted model. We store the sum of squared residuals from the restricted model. Finally, we obtain the precise F-statistic from its definition. The square of the t-statistic is precisely equal to the F-statistic. Today, we have discussed the relationship between the F-test and the t-test. For a single explanatory variable, the F-statistic is the square of the corresponding t-statistic. Thank you so much for watching 5 Minute Econometrics. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.